And yeah, we just did this now. And now let's think about this. This condition, this case may work when there are already some nodes in the linked list. But when we are inserting the first node in this linked list, would this work? Just think about this. What is going to happen when the first node, when we are going to call this function insert_at_n to insert the first node in the linked list? So what is going to be the value of head that is passed into this function? When the first node is inserted at line 10, when we call this function, what is going to be the value of head? It is just null. From the previous line, we can see we have initialized head to null, and so we just pass in null. And so the value that is assigned here for current is also null. Current also points to null. And when we come and try accessing this particular line of code, current.next, we are trying to say dereference a pointer called current, which points to null, which is like wrong. Okay, which is like null is address 0, and address 0 is like reserved address. We can't really dereference that particular address. And so it throws a null pointer exception or a segmentation fault. And once that happens, your program will crash. Okay, and so here it is really important. If you want, we can just try that out. Okay. So they say like null is an undeclared identifier. Okay, so to use null, we have to null will be defined in some header files. I think it's standard library. Okay, let's check that. Yeah, and even malloc. Okay, even malloc is defined in standard library, and so standard lib.h. Once you declare that, now you are able to like compile this program. And when we try to run this program, it says segmentation fault core dumped, which was mainly because of the reason that I just showed. We are trying to dereference a null pointer, okay, which is wrong. And so your program, the operating system immediately kills your program or terminates your program. Okay. And to avoid this, what we are going to do now is we are just going to see how can we avoid this. So for the first node that we are actually inserting in the linked list, we should handle it separately as a special case. So in this case, let's assume this is going to be the first node. Okay. So how can we figure that out? If the head that we just got inside this function, or if the current, both are the same right now, if the head is equals null. Okay, if the head equals null, then it's going to be the list is empty. So the element that we are adding is the first element in the linked list. And in order to change, okay, in order to add this element to the linked list, what should happen really? Just think about it. Exactly. So we should repoint our head to the new node. Okay. So we have two things here. We were in main. Okay. And main had a head. And initially it's empty, it's null. Okay. And then we just insert. Let's assume this is a function insert. We passed this head to this function. But now whatever we just got here is a copy of that variable with the same value null. It's not the same variable. This is very important here. Okay, this is very important to understand here. When we just passed the value of head to insert, we just have a new variable called head inside insert's stack frame. Okay, and that is also pointing to null. Now we also have one more variable that we created called current, which is also null because we just assigned head to current. And we also have some memory in the heap. This is the heap side, okay, with some value. Let's assume like first, since this is the first node, let's just assume we are inserting a value of 10, and we made this null, and we have a pointer from the insert stack frame called new node, okay, which is pointing here. This is the scenario that we have currently, okay. Now, if we make head point to the first node inside insert, now head is going to be pointing to here, the same place where new node is pointing to, okay. Two pointers can point to some same region of memory on the heap. It's not a problem at all, okay. Two pointers are pointing to the same region of memory. But let's see, okay. So if we just have like head equals, head is a pointer, okay, head equals new node, okay. Will this work? Why? Exactly. So this is not going to work. This piece of code, the lines 25 to 27, will do this assignment for this head to point to this node, but it is not really going to change the head in the main, okay? And so you may think that you have inserted something, but once this function completes, all these are gone. This still remains, okay? Heap will persist, the things on the heap will persist till the end of your program. And so these things remain, but all these local variables on the stack of insert are gone. And so when you go back to main, you still have an empty linked list, okay? How can we avoid this? How can we make sure that we update this too? Great, that's one of the very good ideas. So a good way to do so is like we can make sure that once we update this head from this function, we can return this new value of head, okay, to the calling function. And if we want to do so, then the things that we need to change are, we are not going to return void anymore. We are going to return a pointer to a struct node, okay? And at the end, so in this case, it's going to return head, but always it should return some pointer to a struct node. And so even in this case, in the case when there are like elements already in the list, even though it really doesn't matter, okay, the head is not going to change, we have to still return head. Okay, this is just for the compilation purpose or syntactic correctness of your program, okay? And yeah, so once this is done, first you should again go and change this function prototype to struct node star, okay? And the way you call it is also going to change now. Since you're returning the value of the head to the calling function, you are going to call it in a different way. You're going to update the head that you have in the main function using the value that is returned from this particular function, which is, in this case, going to be the value of the first node. And this is really needed, okay? This assignment is really needed only for the first node, if you think about this. Because when you add the second node, the head is not going to change. And similarly for subsequent nodes, okay? But this will work.